Hey everyone, welcome back to my channel. Today we're diving into something super important for any network, keeping accurate time. Why does it matter? Well, think about troubleshooting logs, security events, or even just ensure your system communicate correctly. Accurate time is the bedrock for all of it. So grab a coffee and let's do this. We configure our network device to tell the right time, starting with the basic of system clock configuration. Well, every network device has its own internal clock. First up, how do you see what the time on your device? Super simple, just use the command show clock. Now, what if the time is totally off or you just want to set it manually? Maybe you're in a lab environment and don't have an NTP server yet. You can use the clock set command. So, I type clock set HHMMSS day, month and year. Then the example is like this. Clock sets 12:45 0029 July 215. Notice the format: hour, minutes, seconds, then the day, month and year. Pretty straightforward. Now let's talk about time zone and daylight saving. Just like the real world, our network devices need to know their time zone. This is the crucial for local time representation. You set it with clock time zone name, UTS offset. Now let's type clock time zone CST-6. CST is our zone name and -6 is the offset from Coordinate Universal Time or UTS. So Central Standard Time is 6 hours behind UTS, and we want to verify our clock. We type show clock detail. To make sure everything you've just done is correctly, you'll want to use show clock detail. This command gives us your much more comprehensive view, showing not just the time, but also the time zone, daylight saving status, and most importantly, the source of the clock. This is the key for our next topic, NTP. Manually setting clock is fine, but imagine doing that for thousands, hundreds, or even thousands of devices. That's where NTP or Network Time Protocol comes to the rescue. It's how devices synchronize their clock automatically with a central authoritative time source. Let's cover a few quick NTP basics. It uses UTP port 123, good to know for firewall rules. NTP organizes devices in a stratum hierarchy. Think of it like a layer of accuracy. Stratum 1 is incredibly accurate, often directly connected to the automatic clock. The higher the stratum number, the further away it is from the primary source and slightly less accurate. Lower number mean more accurate. When a device acts as an authoritative time source for itself, it uses a special pseudo IP 127.127.x1 and a pro tip. When possible, use loopback interface for NTP. They are always up and stable, making for a much more reliable time source. For our example, let's say we have a device DLS1 that we want to be our authoritative NTP server. It will tell other device what time is it. To make DLS an NTP master, we use NTP master 10. We're setting its stratum to 10 here. You could choose lower number if it's connect to a very accurate source, but 10 is good starting point for an internal network master. For security, we absolutely want to enable NTP authentication. This prevents unauthorized device for messing with our time. First, NTP authenticate. Enable it globally. The NTP authentication key 1 MD5 password set up our key. We're using key ID 1 MD5 encryption and password as our secret. Remember, In a real network, use a strong, complex password. Finally, we tell the device to trust this key with NTP trust key 1. Now, for our other device, our network client like or ALS1 or ALS2, they need to know who to ask for the time. We point them to our network and NTP server with NTP server 172.16.99.1. Just like on the server, we enable authentication and use the exact same key for security. NTP authentication, NTP authenticate, NTP authentication key 1, MD5 password, NTP trust key 1. And don't forget to set the time zone and daylight saving on your client too, as we did earlier. Clock time zone CST -6. We want to set up client NTP. We assign an IP of the NTP server with the NTP server IP, enable authenticate, then NTP authenticate key 1 MD5 password. Then we pair the trust key as we made it before. Clock time zone CST -6. Let's verify NTP status. So how do you know if an NTP is actually working? There are few key commands. Show NTP status. This tells you if the clock is synchronized. Show NTP associations. This command show you NTP pair, who you're getting time from and their status. And finally, show clock details again. This time, look for the source is NTP. When you see this output, you know your NTP is humming along, keeping your network or schedule. And that's it. You configure your campus switches to synchronize time using NTP, secure it using MD5 authentication and access list, and verify synchronization across the board. Time might seem like a small detail, but in the real world networking, it's everything. If you found this helpful, give it a like and don't forget to subscribe for more CCNP lab and network training videos. Thanks for watching and I'll see you in the next lab.